Alright, welcome to Computer Science 305, Programming Languages, and yet again we're working on a in-class exercise. This is from the second part of Language Systems, and what we are looking at is it's in another one of the problems where we had a system that was an assembler language with the 5 shown assembly instructions, and so we talked about them in the previous in one of the previous videos, which we had load, which loads something from an address into a register, add, which adds the second register to the first and then stores it in the third register, sub, which subtracts the second register from the first and then puts that value in the third, multiply, which multiplies the second by the first by the second, and stores the product in the third register, and then store, which stores value from the register into the address. And so we then had a couple of problems that we could do. And the first one was we wanted to solve or translate cube equals x times x times x, right? So the cube value of this. And so pretty simple translation. This one we can do it in 4 at least. 4 instructions, right? So we load from x to register 1, and then we want to multiply register 1 by register 1, and then we'll store that in register 2. And then we want to multiply register 1 by register 2, and then store that in register 1, and then store the entire value from register 1 in the address at cube. So that one was pretty easy day, no problems there. The second problem was a bit longer, and so I'll write that out. Was to take it's a really long multiplication subtraction. So we had the sum of a minus a base multiplied by the sum b minus b base multiplied by c minus c base, right? So this one, is of all the ones we've done, would actually require us, I'll actually let you see it, would require us to use the 3 registers available to us. So first off, we need to load A into register 1, load A base into register 2, and then we're going to perform the subtraction. So we subtract register 2 from register 1, store that back in register 1 again, and then we're going to load B into register 2, load B base into register 3, and we're going to subtract R3, we're going to subtract R3 from R2, 3 from R2, and store that in R2. And then we need to perform the multiplication. So we've done the subtraction of A base from A and B base from B. Now we need to multiply to find that product. And so we do that. That will give us, so we say mul, and we have R1 by R2, and store that in R1. So now R2 and R3 are available again. And so we need to do the C minus C base. So we will do that. So first we need to load C into R2, load C base into R3, and then we will go ahead and perform the subtraction. So that'd be R2 minus R3, and we'll store that in R2. And then we need to do the final multiplication, which is R1 by R2, store that to R1, and then we can store overall the value at R1 into the address for final. and that completes that translation. So that's pretty easy problem to solve. There are much more difficult problems in the book, not in this area, but instead of we would be taking the assembler language we have here and codifying it. And so I leave that as maybe an exercise that you might want to do on your own, especially if you are looking to take compilers. It's something that you might want to know about and try to figure out on how to do that. I'm thinking about possibly putting that also on the homework. So anyway, have a good day, and we'll talk to you all later.